a data set using this random generating function. All right, random number generating function. You know, you don't want that data set to be changing from time to time. Are we together? So you don't want it to be changing from time to time. So that is where the set seed comes in. So if you say set.seed, let's say 1, 2, 3, 1, 2, 3. So if I should run this first, all right, and I run this particular line of code, with which I want to generate those 20 elements. So if I should run this now, okay, so I have 27.33. That's the first element, isn't it? If I should run it again, and I come back here to run it, okay, I'm still going to have, I'm going to run the set seed again. Then if I should run this, I'm still going to have the same element, 27.33. You said you'll be getting, it's not changing. How did you do it? No, you have not done it the way I did it. See the way I did it. Let me do something. Let me put print. You can't get the same number. It's not possible if you have done it correctly. So let's see. I'm going to run this. How do I? So I'm not going to be using the set.seed again now. So look at it. I'm not using set.seed for now. All right. So I have the first element is what? So let's run this again. I'm going to run this all over again. Okay. What do I have? So I'm going to be running this all over again. I'm running the two lines, 1, 2. No, you can't get the same thing if you run the two all over again. Check it out. Don't run the set seed now. It's changing. It should change. All right? It should change. Is it changing? Don't run the set seed. Run those two codes, those two lines of code over again. It should be changing. Is it? Right? So now the purpose of the set seed is this. So the set seed is like you are assigning, it helps you to assign that vector of elements to a particular, as though to a particular password. That wherever you call that password and you are using, you want to generate this random number, it is those ones that it outputs to you. So for instance, now let's look at it. If I do set seed 1, 2, 3, okay? Now, one thing is that if I'm using 1, 2, 3 and you are using another number, our output will be different. Are we together now? So if I do this, I should run this now. I have 27.33, isn't it? Now, if I want to rerun, I will have to run the set seed again. Okay? If I run the set seed again and I run everything all over, I'm still going to have 27.33 as my first element. All the elements will be the same as the former. If you look at this is 1, 2. If you look at the sixth element in the second one I ran, and this is 2.646, and you look at the sixth element in the first one I ran, it is still 2.646. Why? Because I have used set.seed rather. So that's the function of that set.seed. When you are generating random elements, all right, to keep it fixed, so you do the set.seed. Now, another thing again is you can use other functions on this run. Say, for instance, now we want to round our numbers to maybe to the whole number. We don't want the decimal places or anything. All right. So we just come here and just put round. Are we there? Just have our round, and then that just give us whole number. without the decimal places, because the default of the round function is 0. The number of the decimal places, the default is 0. So I don't need to put 0 because that's the default. But if I want it to be one decimal place, I will have to put round. So here I will put comma 1, and this will give me to one decimal place. Don't forget, I want to keep it constant, so we are going to have it to one decimal place. Please, are we together? So let's take, for instance, now maybe we want to generate, where do we use this? Let's say, for instance, we want to generate maybe cases of malaria for 2 years, monthly cases of malaria for 2 years, or monthly cases of measles for 2 years. 2 years is equivalent to how many months now? 24, isn't it? And we want, let's say we have 24. Okay, let me say randomly generate maybe malaria cases. Let's just say malaria cases for 2 years. Okay, mal 2 years. Okay, so what do? I just do round. I have the run if. I need 24 elements, isn't it? Please, are we together? We have 24 elements. Then maybe the minimum number of cases we want is, let's say, 4,300, or let me say 315. I want the maximum to be around 98,600, for instance. Okay. So if I do print mal 2 years, so I need to do set seed. Let me set seed for this guy. 1, 2, 3. Sorry, set seed. Thank you. All right. So I'm going to run this. So if I print this, so I have, so this is randomly generated. Randomly generated. Right? So we have this randomly generated. Are we there? No, let's explain what? 122? 122? You mean this line? Yes. So what we have just done here is we created random cases of malaria with the minimum being 4,315 cases and the maximum being 98,600 cases, right? And then we need 24 of it. We need 24 entries to be in our vector. So the purpose of this round, since cases cannot be in decimal places, for instance now, if you say how many cases did you record, cases of malaria did you record last month? If I say 43,000.5, does that make sense? Does it make sense? No. So we need to have it in whole number or as positive integers. So that is the purpose of this round here, that whatever the output of this is going to be, please round this to the nearest whole number. So that is what this one here is doing. But don't forget that we have used this run if, as the case may be, let me just call it that way, to randomly generate those number of cases. Is that fine? Are we fine with that now? All right, so let's just go straight to the next thing. So we can play around this. We can also come up with our own example. So that's just how to use set seed. So there are other distribution functions that we can use to randomly generate numbers. Like for instance, we have the rnorm for normal distribution. We have the rpoise for Poisson distribution. So that also can be used. We can just use question mark rnorm, rpoise to get more information from the documentation on each of these functions. So now let's go to so we have done something like this the last time. So here we have this one is just to combine the 3 vectors that we created the last time. So this one we can do. I don't want to really bore us with this. So now the only simple addition here is the use of this factor. The use of this factor. That's just the only difference. And what do we do here now? Here is the months representing January to December. So now you use these levels to give it order. Levels as though to give it a kind of to give it order. Which one should come first? Which one should come next? Please, are we together? Are we together? So that's just what this factor, that is just what it does. So you give that levels is just to give order to the arrangement that we have inside of months. Let's take, for instance, let me just give us a typical example. Let's take, for instance, now, maybe we have gender. We have gender, which is just, let me say, female, and then male. Okay. So now, but I want to give it order in such a way that maybe male should come first, then female later. So I can do something like factor, just for us to see what I want to do. Let me first create this. We have factor, then we have gender. So I'm not saying levels, right? So I'm not saying that let it be male and female. So can you see that now? So we have, so it has given it level. In the gender, we have female and male, isn't it? Please, are we together? But when I did the factoring of it, so you can see that it's telling me now that even though this is female and male, but the level is male, female. So it is as though if I say that this one is if I say this one is 1 and this one is 0, because I've created level, this one become 0 and 1. Now, a typical example again is I'm coming. Let's see, month. So this one may take time. January. Okay, let me just. I'm coming, please. I want to manage time at the same time. We have created month earlier, right? Okay, that's what we have here. We have. Okay, let me just use month.abb, right? And I'm now creating this particular month. Yeah. So here we have months, which is month.abb, isn't it? Please note that, let me ask, this and this, are they the same? This and this, are they the same? They're not the same. So let me use the conventional something here. So let me run this, and then let me print what is in month. Please, can we see? Can we see? We have January to December, isn't it? And then we have the levels. The levels give us the order in which this one should come as our output. Are we getting it now? It gives us the order by which our months, which is what we have created here, to come out. So because where do we need this? We may see this challenge later. Where do we need it? There are times when you are trying to plot, it happens sometimes when you are trying to plot a particular data, all right? On the x-axis, you just see a mix up of the month. For instance, now you may see January, or let's say December appearing, followed by November. Then after November, you see January. After the January, you see December, you see April. You come back and see March. On the on the x-axis. So sometimes you want to restructure that as to follow the particular order. So we can use this factor of 18 actually to do that. Okay, so let's continue. Huh. This, okay, quantity, again, same the plot. Find the plot. Can I continue now? Okay, I'm coming. Let me just bring this down. Is that? Where again? We have done that. We've gone beyond that. Set seed, all of those. That's all. Are we done with that? We have many things to do today. We have many things to do. The faster we had, the better. Can I move on now? I only need one no. Can I now? Thank you for saying yes, so I can move on. All right. So we have um, a richer district level data frame. So now we want to create a richer data frame. Want to go a bit higher now. We've done something simple. At least we have a kind of background. So please let's go up. Let's go higher a little, so, because we'll be making use of some of these data sets to run visualization. So please. So now data frames can also hold data generated on the fly. Here we simulate constitutional malaria data for health districts. So please, let's pay attention to this one. So by now, you know what this one represents, isn't it? Right? Right. It's too small. Uh, be okay now. If I enlarge it, every other thing will know. Is it okay like this? But you are not seeing this other side. Okay, maybe do you like me scrolling left and right? You like that? All right. I only need one yes. You like that? It's all right. I only need one yes. Just one yes. All right. So now, the next thing I want us to see is paste. We have paste. So now, what paste does is this. Please, let's pay attention. The last time I took us through cat, isn't it? And I said that cat, you can make custom output of your results using cat. For instance, now maybe you found the mean of a particular row or of a particular column, and you want to say the mean is, are you getting it now, as your output, you can use cat, isn't it? Now, paste is another one that work with strings or character. So what paste does is that, like what we have here, we have paste, district, letters 1 to 8. These letters 1 to 8 is actually a built-in function in R. Are we there? These letters, this particular one, forget the 1 to 8 now. Letters is a built-in function in R. Are we there? Should we check what it represents? Okay, let's quickly do that. So how do we check? So please check what it represents. Question mark letters and see what that represents. Please, let's be fast. I only need one person to tell me, yes, I've seen it. The issue now is that nobody will talk. I only want person to say, yes, I've seen it. All right. Do you also see small letters? You should also see small letters, isn't it? So it shows you that, and you know that uppercase letters means A to Z in the uppercase, isn't it? Therefore, the small one, same A to Z, but now in the lowercase. So that is giving us the vector of the English alphabet A to Z. That is letters. But now, if we now put in that braces 1 to 8, what does that mean? Best 8 elements, isn't it? Within our A to Z. So now, if I do paste, all right, district. So it's like we are interested in getting data set for 8 districts, and those districts want to label them district A, B, C, and like that. Are we following now? So if I say district, comma, letters 1 to 8, are we there? If I should run this now, you are going to see here district A, district B, because we use the function paste. Paste this output to this. So the output now we have on the letters, we have how many outputs? 8, isn't it? So you have A to district, paste B to district, C to district, and that is what we just have in this place. And the output also is a vector. That's why you are seeing here 1, you are seeing here 6, telling you that the first element is the district A, the sixth element is the district F. Are we following? Let me, we're not seeing it again. See it here. Are we fine now? Mm. Something like that. Oh, you are my wonderful friend. You are my wonderful. You are my... This is it, my dear friend. Thank you so much. All right. Are we together? Yes. I should scroll up. Scroll up where? This is just what we have. Nothing more than that. We've gone beyond here. So this is where we are now. Right? So use paste. We want to use this to achieve something. We want to create a richer data set. So this is just one out of other things we want to do. Okay. So let's take, for instance, now maybe we want to get the month, the first 8 months. What are we going to do? Do we need month? Month dot. All right. That one does not need paste. Are you getting it now? Because what we are doing here now is that we are creating vector. Are we there now? So it is these vectors that will combine together to make a data frame that become our data set. Are we getting it now? So that is, so it is like we are doing everything here in bits. Okay. So now I'm just trying to explain some of the things we have here so that you'll be able to follow when we are to create this particular data set now. Do you see the data set? Can we see the data set? So I want to believe that what you are seeing here, you understand it. Yes, ma'am. Yes. 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 So yes, if you look at after set seed, we have n underscore discrete assigned to it, isn't it? So actually what they are will be seen as n discrete will be what now? 8. Are we there? I want us to see this, and do you understand what you are seeing on the board? Our yes is very low. Do you understand what you are seeing on the screen? I want us to look at it. We have just done this. We are only randomly generating numbers, isn't it? Right? And for data frame, please let us take note. For data frame, because in data frame we have column names, we have rows and columns, isn't it? Now, along the columns, the number of elements must be the same. Are we together? Do you get what I'm saying? Okay, so now see what I'm saying here. Let me quickly take us through this. Um, let's say now see what I'm saying. We have our table. Our data frame is just like a table kind of, isn't it? Then in that table we have rows and columns. True or false? Right? So what I'm saying is this: if these are the column, for instance, okay, and here, let's say the first one, that's where we have the column names. So these other ones, let's take, for instance, here now we have this and this. What I'm now saying is, don't forget that if this one is, let's say, vector 1, and this is vector 2, this is vector 3, all right? Don't forget that those vectors are what we combine together to make a data frame, isn't it? What I'm not saying is that the entries in your vectors must be the same. That means the length of all the vectors must be the same. That is why repeatedly in this place, look at, that's why repeatedly in this place, that's why repeatedly in this place, you can see run if, end district, end district, end district, end district. What is that telling you? It's telling you the length. And you have predefined the length to be equal to what? To be 8. This is to ensure that each of the vector, look at this. This is going to give you a vector. This second one is going to give you a vector. The third one is going to give you a vector. Are we there? And what we are just seeing here is how the entries in those vectors are generated. Like for instance, now for the population, we said for the population, let it be between 50,000 and what? 300,000. Are we together? For the cases, let it be between 500 and what? 8,000. The bed net percentage, that is the percentage of bed nets used across the district, let it be between 20% to 85%. For the IRS percentage, let it be between 10% to 70%. Are we getting that now? Are we getting that? People are not responding. It's like adult class is different from. Is it? But I've been training adults. Are we together? Okay, it's like adults are different. Okay, let's continue. All right. By now, you should be done with this. But yes, no, both understanding and typing it. Oh, yeah, be fast now, be fast. Just copy and paste. Copy and paste. No, see, hold on. See what I'm saying. See what I'm saying? You only need, after this first one, you only need the second one. After you've done this, just copy this one, copy it here, change the number, 500, this and this, copy this one, paste 2085, copy it again, 1070. That's all. Okay, we're not seeing it yet. And now, I only need the first person to finish. The what? And yes, the set.seed 42, you also have to do that. Because that's what we make those entries to be unique. So that when you run it again, you will not be seeing another output. And you're saying it's like, yes, just as it is. We have 1 minute left. Just copy and paste population equals to copy and paste. This is 23, copy and paste, 500, 800, copy and paste. We still have a long way to go. I only need one person to say, yes, I'm done. Just one person. One person, just one person. The person can be one of the Camda members. Just one person. Ah. Somebody is done now. Somebody is true. I can see that person. I can see that person. Somebody is done. I only need one. No. Are we done now? Thank you. All right. So we have to move fast. We need to move very fast. Now, one of the things that can also aid, you know, why I'm leaving us to type these things, because I want us to understand it. As you're typing, there's a way you understand it, make your brain connect. That okay. You type the first one, the second one. Oh, this is what this one means. You're able to understand, so that by the time we'll be moving to the next thing, then I'll just say, okay, let me just copy and paste for you, but it's not going to really help in a way. So now, after you have done that, when you're done with that district, can you type district under and run it, so that you can see the table that you have created, the data frame you have created. You should have something that looks like this. You should have something that looks like this. You can use view, capital V, view, then put district inside that you have the table like output. Can we continue now? All right, so I need to move. All right, please, for those of us who are done, please just copy from your friends or your colleague beside you, your neighbor. Just check your neighborhood. Somebody's. And another thing you can do also is snap it, put your phone beside you, then you are typing it. So, um, elevating and depressing all the time. Elevation, depressing, right? Just copy it, snap it, then place the phone beside you, and just to avoid this angle of elevation and depression. All right, so now we move. Okay, you want to snap it? Okay, snap. Don't forget your commas. The commas that should come immediately after each of the vector. Are we there? Can I continue now? I only need one no. Can I continue? Thank you. So now, the next thing we want to check is what we call the pipe operator. The pipe operator. What do we use the pipe operator for? You are still going to see it here now. So the pipe operator is just to pass results on its left into a function on its right. Just imagine pipe, the normal pipe that we have. All right. So, and you know, on the left, let's take for instance now, this is for me, this is my left, this is my right. If I'm passing something through here, it enters there. I see the output on the right, isn't it? I put it here, I see it on the right. So that's what the pipe function also does, the pipe operator also do. So you have this output you want to pass into another function to get another output. You can use the pipe operator just to do that. You can use the pipe operator just to do that. And that's what we have here. Said the pipe operator passes the result on its left into the function on its right as the first argument. So that is what it does. Are we together? Are we together? All right. So I said the pipe operator. So what it does is that it's like, for instance, now you've gotten an output somewhere. All right. So now you want to pass that output into another function. Okay. So with the head of the pipe operator, you can pass that result into that function. So now the function sees that output as its first argument. That does it. The pipe operator.
Can we have all ICAMDA interns and masters scholars stand up, please? Please just stand up. ICAMDA interns and scholars, please stand up.
So then we have this other one.
I want them to help us. Please, can we make it very fast? I'm not seeing us stand up. Where are the ICAMDA scholars? Please, can you move forward? Just be fast. Move forward, please. Let's be fast. Move forward. Just come forward. This class is dragging and you are seated. You are not helping people. Please come forward. Come forward. Be fast, please. Favor and Co. Please, can you come forward? Those at the back seated. I don't know. You are still sitting now. Can you please run forward? So, two of you, man that place. Thank you. Please join them in that place. So when somebody is in need of something, just put up your hand. Is that okay? Somebody will come to you.
So when you're in need of anything, just raise your hand.
Daniel, please, can you come forward? Please be fast.
You can easily come to your head.
Ablasi, please come forward. Be fast. Let's be fast, please. There's no time. This. So please, can you join this place? Join that place, please. Joshua, please, that place. It's just move into the audience, please. So that in case, so please, once you, because the facilitator needs to move very fast. We have a long way to go today.
Very
fast. I can see the way we are moving, we may not be able to cover so much. So once it gets to a place and then you are not getting it, just put up your hand. Somebody will come to you. Is that okay? All right, thank you.
Okay, thank you. All right, so we have this. So I just talked about the pipe operator, then mutate. So now what mutate does is, so let's say for instance, you already have your data frame. Please, are we together? You already have your data frame, but in that data frame, you want to create another column using existing columns in your data frame. Are we together? So you can use mutate to create another column, adding it to your data frame. Are we together? So let's take for instance now, maybe you have you want to calculate, for instance, in that district, just like we have in this place, you want to derive incidents per 1,000 population and attach it as a new column. Can we see that? You know, in the data set already, we have the number of cases according to each of the districts, isn't it? So now let's take, for instance, that you want to derive incidents per 1,000 population. You want to know how many cases do we have per 1,000 population, and that will give us what we call the incidence rate. Are we there? So now, how do you do that without having to maybe do a lot of things? So you can just use mutate just to do that. And how is that achieved? So you can still see here that we are still making use of our district, which is our original data frame. Are you getting it now? All right. And let me please say here. Please, are we together? Are we together? Please let me quickly say something here also. R overrides. R overrides. What do I mean by saying override? Let's say, for instance, now you assign an object to a particular variable name. Let's say you assign 5 to X. Are we there? At another point, you assign 7 to X. When you run the first one, you see X equals to 5. But when you run the second one, you have X equals to 7. By the time you are saying print X, it's not going to print X equals to 5. It's going to print out X equals to 7. Why? The last one has overwritten the former. Are we together now? Please, are we there? So here now you will see that we have already declared district as our data frame, isn't it? Now, I want to add another column to it. Because it is still the same data set I still want to have, but with the addition of a new column called district, I will still call back that district again. So whatever I'm going to do now, by the time I run district, it's going to overwrite the former one and will be giving me the new one now containing the new column that I have added to it. And that is what we want to achieve. And that's why you are seeing the district. You can see district. You can see what? Can we see it now? All right. So you can see here now, we have what we want to derive. Please let us get this right so that we know what we are doing. We want to derive incidence per 1,000 population and attach it as a new column. Are you getting it now? And that we want to achieve by using already existing entries in our data frame. All right. So the particular column that has what we need is we have the case underscore 2023 and also the population, because for you to get the incidence rate, all right, if you want to get the incidence rate, what you just do is you look at how many cases, all right, what is the population. So if it is per 1,000, then you multiply it by 1,000. If it is per 100,000, you multiply it by 100,000, and that won't give you the incidence rate. Please, are we together? Are we together? So now here we want to get incidence per 1,000 population, and we are now saying that to get that, all right, we want to round cases underscore 2023 where we have the cases, divided by the population, then times 1,000, leaving the answer to one decimal place. You can see that we have here round, isn't it? Cases over population times 1,000. That is the incidence 1,000 population, round it to one decimal place, and whatever the output is, assign it to this column name, which is incidence per 1,000 population, using this function called mutate. Are we there? By the time we run district now, the column names will have increased by 1, or our number of columns will have increased by 1. Why? Because we have created another one, which is incidence per 1,000. That is the function of that mutate. Are we getting it now? The pipe operator, what that pipe operator does, like I said, is that it brings this data set, district, into this particular function mutate. Are we there now? what this pipe function does, like I explained earlier, is that it brings this data frame district as the first argument of this function mutate. Are you getting it now? So mutate is seeing district. It's not going to be acting on it in order to create incidents per 1,000 population. Do we get that? Can I take that again? Normally, if I have to use mutate, normally we're supposed to do, see, this is what we're supposed to do. We're supposed to do, let me say, incidents. We're supposed to do something like incidents, or we say mutate. All right. Then I will put district, which is the data. Look at. If I just press mutate now, see, can you see? There must be a data after the mutate as the first argument of mutate, isn't it? Can we see data? Right? There must be a data. So now, but the way I'm defining it here now, look at that data. This is it here, isn't it? So I'm not saying that this data pass it into this mutate function. Are we seeing that now? So this is like a pipe. So it's passing district into this function. So and that becomes the first argument of this. And with that, create this particular column called incidents per 1,000. And how do I get the entries of that column? Do it this way. Round cases of 2023 over the population times 1,000 and give me the answer to one decimal place. Are we getting it now? Have we done that? After you have done that, then run district again. You will see that your new output now will have that column added to the former, which is incidents per 1,000. Are we there? Are we done with that? I only need one no. We have few, just our time is almost up and we have not done so much. Even if you look at your own R script, you will see that we have not done so much. Right? Can I continue now? So if you run district, you should see the added column name now, incidents per 1,000. And you can confirm that by saying you can confirm that by checking names, districts. You should have the incidents per 1,000 added to your columns. Right? Right? Are we there? All right, so let's continue, please. I can see that we've already gotten that. So please, if we need further help, just check your neighbor, check within your neighborhood, somebody who have finished, check what the person has done, then just use it to complete yours. Very important. So now we can get summary. We can get summary of the data set. Now the summary function goes to every column that has numeric entries. And give us the summary. The summary includes the minimum, the maximum, the mean, the first quartile, the third quartile, and the maximum, just like what we are seeing in this place. All right. So if we check the summary of district, summary district, right? Going to have to check summary of districts, gives you overview of give you a kind of descriptive statistics within your of columns having numeric entries in your data frame. As you can see, population cases underscore 23, the bed net percentage, IRS percentage, incidence per 1,000. So you can see the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. So you have that descriptive statistics from your. So this one give you, with this you get information about your data set. Yeah. Okay, maybe boy, I want a library, deep line, but no, I bet you share that is a normal something. I don't think it's. How many of us have been able to get through up to summary of statistics of the data frame? Summary. How many of us has gotten up to summary? Please, you need to install the dplyr, and or load it, just library for the pipe operator. Yeah, already have it loaded. Yes, Baba. Okay. All right. I guess we installed dplyr in one of our classes, isn't it? So the pipe operator may not work now because maybe you have not imported that library. So just import it, run it, then try it again. You should get your output. Okay. So how many of us has gotten it up to summary? Today, I want to see our hands up. I want to be sure people are getting it. Up, 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 up. Very good, very good, very good. It's okay. So let me see. We are still here. We have gone beyond here. How many of us have got up to summary of districts? Wow, I can see hands at the back too. Very good. Are we there? This one? All right. You can snap just to make it easier. Snap then. Just the what? The summary. Summary just summary then district. That's all. No, forget this one for now. Don't use this one for now. Forget what we are seeing here. Just use the one I used here. I'm still going to explain something here. Just use this one I used. This one. Summary. Right? Which one do you need again? That's what we have here already. Here. Right? So how many of us have been able to get it up to the summary? All right. So can I continue? Okay. All right. So now, but if please let's pay attention. If you want to get, if you are interested in maybe it's not helpful. The time is not helpful. Yes. Ah, I will not use Nigerian time again. Let me go to Ghana. That we are 1 hour ahead of them. So it's like, I will go to Ghana. Go to Ghana. All right. So let me just quickly explain this line. Where I was told that my time is up. I will assume we are in Ghana. Nigeria is 1 hour ahead of Ghana. We have 1 hour left. Are we there? So nice that Ghana is in West Africa. Very good. Very good. So now, so what I just want to say here is, let's say for instance, you're only just interested in not all the column with numeric entries, maybe just specific columns, just to get a kind of overview of maybe the minimum, the maximum, first quartile, third quartile, the median, the mean. So you can do what we call subsetting. All right, the subsetting of the data frame, and that you do by just what we have here. District is our data frame. Okay, so actually for you to do subsetting of a data frame, you need the rows and the column. Please, are we following? Please, are we following? All right, so let me just quickly explain that. For the subsetting, So let's take, for instance, now, here we have our data frame, okay? Sorry. So here we have our data frame. So here we have, let's say this is column 4, this is column 5, this is column 6, for instance, okay? And now you want to do subsetting. What that means is that you want to extract just a subset of the data frame. Maybe a number of columns with the corresponding number of rows. Let's say, for instance, maybe you want to subset. This is row 1, row 2, row 3, row 4. So you only need from row 1 to row 4, R1 to R4, for instance. Okay? And for that, you only need the corresponding columns to be maybe just column 1 to 3, for instance. That means you need just only this place to this place. Are we there? Don't forget our data frame is rows and columns. Is that correct? Is that correct? All right. So how do we do that, for instance? So let's say if I should go back to district. So let's say I want to get the first 3 columns. Are you getting it now? And for the first 3 columns, I want to get the first 4 elements of the first 3 columns. All right. To get that subset, what I just need to do is, so let's come here. I'm just going to do, I will just do district. All right. Excuse me, please. District. So I can do something like for the rows, I need the first 3 rows. I mean, the first 4 rows, isn't it? I have 1 to 4. And for the columns, I need the first 3, isn't it? I'll do 1 to 3. So if I should run this, I'm going to have this. Let me bring this down. Can we see that? I was able to get that subset because our data frame is rows and columns. Are we there? So for the rows, I need the first 4 rows, 1 to 4. For the columns, I need the first 3. That will be 1 to 3. Are you getting it now? Because the data frame is row by column. Are we together? Are we together? And there are times that you don't want to use, maybe for the column names, the columns take the column names. You don't want to use 1 to 3. All right. Probably because maybe column 1 has character entries. And the sum you want to do, you need it for numeric entries, isn't it? So you can use the column names as to extract the subset. Let's say, for instance, instead of saying 1 to 3, I can say C into, then you need to be aware of the column names. So let me just quickly get that. I think I brought it out the other time, something like that. Okay, so I have, let's say, population. I want to get for the population. You will see now that the first column name, which is district, the entries are not numeric. Are they? Are they numeric? No, so I can't say 1 to 3 again. Are you getting it now? Because that one, which is for column 1, it's not having numeric entries. So I go by the numeric names, comma, to do subsetting. Then by maybe cases 2020. Don't forget you have to put them in quotes. And then maybe the last one, maybe percentage of bed nets in columns also. All right. So if I should run this now, sorry about that. What is saying? My time is up. On the 5 column, yeah. On the 5 column selected. Undefined. Yes. Okay, so here we have it. Right? The time is up. So, and we need to stop here today. So, what we are now looking at is that the the, the mop up, the pre-class we do hold in the morning. So instead of Python tomorrow morning, I'll be coming to take us on R, because the aspect we will not be able to cover now, which is data visualization using the ggplot, and that is very, very key to the project and our learning data analysis. So tomorrow morning, please let us meet as early as possible. I think that is 9:30. Is it 9 or 9:30? 9:30. Let's meet 9:30 on dot tomorrow to go through um, data visualization using ggplot. With that, I want to say thanks so much.
A round of applause for our facilitator. If you agree with me that this was a practice section, and so we want to do something, if you were able to follow through from the beginning till the last code, can I see your hands up? I was able to follow through from the beginning of the code till the last. Your hands up, please. Okay. I can't see the hands, so. All right. A round of applause for yourselves, please. I was not able to follow the code through from the beginning to the end. Let me see your hands. I could not do anything at all. Let me see your hands, please. Okay. I can't see your hands, so if you were not able to do anything, please raise your hands. Above your head, we need to see them. Nobody. Okay. But then if you started and you could not finish the code, let me see your hands. Okay.